Hello everyone! In Oracle, a sequence is used for generating unique numeric values. The sequence has an initial value, a step, and a maximum value. Let's determine the speed of the sequence. That is, how many unique values we can request through a specific sequence per second. Additionally, by knowing the maximum value that the sequence can provide, let's determine its lifespan in years. In other words, if we were to continuously obtain new unique values from the sequence at a certain rate, when would we reach the maximum value? Let's explore option with caching, where Oracle holds a certain batch of new values from the sequence in cache and provide the next sequence value from the cache when requested. We will consider several cache size options, as well as an option without caching. All tests will be performed in a single and multi-thread mode. One way to implement this test is to sequentially recreate the sequence with one of the caching options and initiate the generation of new values in 1, 2, 3, 5, and 10 threads. To mitigate the impact of background auth activity spikes, we will call the next value function in a loop for 1 minute, and later convert the obtained result into seconds. Let's go. We will create parallel processing using auth facilities by launching SQL Plus with the start command. Here 2 represents the total number of threads, and 1 and 2 represent individual threads. The test lasted for 50 minutes, and as a result you obtain logs for each test case. Additionally, the results were stored in Oracle table. By means of an SQL query, let's retrieve the result in an aggregated and readable format. We will display which sequence instruction was used, the read speed of the sequence per second in each of the threads, as well as lifespan of a sequence in years. Where 1, 2, 3, 5, and 10 represent the total number of threads in each of the test cases, 2_1, 2_2, etc. represent the result for each of the threads. Let's visualize these numbers of graphs to make the results easy to comprehend. The histogram depicts the results of generating new values for sequence per second when launching in 1 thread, 2, 3, 5, and 10 threads. The data is represented separately for each thread. For example, when launching in 2 threads with the no cache option, each thread managed to generate around 3,500 unique values. These graphs confirm parallel execution, showing that each thread consistently received CPU time on average. It's also observed that with the same total number of threads, adding the default cache cache 20 compared to no cache increase the sequence speed by 5 times. However, subsequent increases in the cache size don't further increase the speed. This is likely related to the specific characteristic of my computer on which the test case were run. So, on my computer, there is only one physical processor and 8 virtual ones. The database server is also deployed on my computer. In this configuration, the cache size is not limited factor. On the following graphs, we can observe that at the same cache size, parallelism provides an attempt two-fold increase compared to one single processor mode. Moreover, further increasing the number of parallel threads continues to enhance the total count of IDs generated by the sequence. Here's another interpretation of the data similar to what we observed in the histogram by aggregated across the total number of threads used in the test cases. We can see that transitioning from no cache to caching result in a 5-fold speed increase. However, due to the limited resource of the computer where the test case were run, subsequent increases in the cache size don't impact the speed. This is also supported by the no cache graph. If parallel execution starts with more than 3 threads, the speed of generating new IDs with the same sequence begins to decline because the threads start competing for the limited number of processors. Finally, let's look at the lifetime of the sequence in years. If I were to run the generation of new IDs with the sequence in an infinite loop, the sequence would reach its maximum value in at least 560 quadrillion years. Let's summarize. The maximum speed of the sequence on my local single-processor computer was 146,788 unique values per second. However, this was pure generation, representing a kind of theoretical maximum. In real-world scenarios, there where generated sequence value is often written to a table along with other data. This would reduce the speed of the sequence. However, this case showing that if, for example, there was a need to generate 200,000 new IDs per second on my machine, it would be necessary to either increase the computer performance or explore solution on NoSQL database. I don't recommend manual parallelization, especially with a publicly accessible service. For instance, if a service parallelizes processing into 10 threads, simultaneous requests from 100 users would attempt to create 1000 threads, significantly slowing down the overall server performance. In Oracle, for such parallelizations, there is real application clusters, where each additional cluster node provides extra computational resources for data processing. The lifetime of my sequence with continuous generation of new values in an infinite loop is estimated at approximately 560 quadrillion years. That's all. Thanks for your attention. See you again. Bye everyone.